Right, question 8. Looks like we've got a Venn diagram. Even numbers less than 30. So we need all the even numbers less than 30 in there. And we're told in set A we have 2, 4, 8, 10, 12. And then in set B 2, 6, 8, 28. Complete the Venn diagram to represent this information. Right, okay, do you know what I'm going to do? I'm going to list all the numbers, all the even numbers here. And then actually we're not going to miss any, because it's a shame to lose a mark just because we missed one number out. But if we list them all, we can cross them off as we go. Right, okay, 2 is in both. Well, let's label that. That's A, that's B. So let's put 2 in the middle, cross 2 out. 4 is just in A, cross that one out. 6 is in B. 8 is in both, so again in the middle. 10 is in A, and basically we're just going to work my way down the list. 12 is in A as well. 14 is not in either, so we have to put it on the outside, but in the rectangle still. Same with 16. In fact, actually the only other number we need to worry about is 28. Doesn't matter where you put these numbers around here. 28 had to go into B. I don't know why I've put 20 there. That should be 30, but actually even numbers less than 30, so we don't need 30. So that's our completed Venn diagram. Now, a number is chosen at random from the universal set. This is the universal set, so all the numbers, all the even numbers less than 30. What is the probability that the number in this set is A and B? So we've got the probability the number is in set A and B. So it's 2. So there's 2 numbers, but out of all of our numbers in total. Okay, which is wrong on the mark scheme by the looks of it. So how many numbers have we got in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 2 out of 14, because we've got 2 that are appearing in both, which gives us 1/7. A and B as those 2 numbers. So actually the mark scheme's wrong. Okay, it is 1/7. Question 9. Right, we need to simplify. So to start with, we need to multiply them out. So 3 times 4, 12x, 3 times 2, 6, and then we mustn't forget this negative here. Collect the like terms together, so we've got 12x and a minus 6x, which gives us 6x, and 6 take away 2 gives us 4, so 6x plus 4. Now, we've got a to the power of 4 all to the power of 5, which basically means we've got a times 4 5 times. Don't have to write it out, I'm just showing you where this has come from, because basically what we can do, we can multiply these 2 together, or indeed add up these 5 4s, but you get a to the power of 20. Another mark. Right, number 10. It's to do with angles by the looks of it. So we've got ABCD is a rectangle. We know that's 50. Work out the size of x. Right, okay, so we know that's 50. Vertically opposite. Doesn't say anything about giving reasons. We can just work out the angle. We know, because angle's on a straight line, this one here must be 130. And then actually, because it's a rectangle, this is meeting in the middle, so that's the same length as that. So what we can do is 180, take away 130, which gives us 50. But because these 2 angles here are the same, it's an isosceles triangle, we can do 50 divided by 2, 25 degrees. But do draw on your diagram. That's really important. You can use that to help you. Right, question 11. Bit of standard form, but we've got negative power here. So that actually means it's a small number, but it's only going to be divided by 1/10. So it's actually 0.47. Now, work out the value. Now, you can do this on your calculator. In fact, we will do this on a calculator. So it is 2.4. There's a little times 10 button on your calculator. Times by 9.5 to the power of, or times 10 to the power of 5. And your calculator, unfortunately, doesn't put it in standard form. So we want it in standard form. It's got to be between 1 and 10. So the actual number on the calculator is 1, 2, 3, 4. Should be 7. 1, 2, 3, 4, 5, 6, 7. Absolutely. So then for our decimal point, or the whole number is moved across once, twice, 3, 4, 5, 6, 7, 8, 9. So it's 2.2 times 10 to the power of 9. Okay, on to the ratio question. We've got the ratio of boys to girls. Number of boys to the number of girls in the school is 4 to 5. There are 60 girls in the school. So let's set this up. We've got boys, girls. We've got 4 to 5, but actually there are 60 girls. And we need to keep it in the same ratio, so we need to figure out what we've multiplied here. So if we do 60 divided by 5, we get 12. So we've times by 12, so therefore we have to times the number of boys by 12 to keep it in the same ratio. So we end up with 48 boys and obviously the 60 girls. All because we did 60 divided by 5. Oh, no, that's not what the question's asking now, is it? Work out the total number of students in the school. So actually, we've got 48 boys, 60 girls, so we end up with 108 in total. Make sure you read the question. Okay, number 13. Another ratio question. The ratio of Mark's age to Rita's age is 3 to 5. Mark's age is 24. We can do this exactly the same method. 3 to 5. So that's Mark's age, Rita's age. Mark is actually 24. So we can do 24 divided by 3, which means we've times by 8. So to get Rita's age, we have to times by 8. And we get 40. So we worked out Rita's age at 40. Now, the ratio of John's age to Sarah's age is 1 to 4. But this time we've got their total age. So that's John. 45. So what we have to do is we have to add the parts together. So 1 add 4 is 5. This is more of a common type of question with ratio. 45 divided by 5 is 9. So actually John is 9 years old, which means Zara is 36 years old. Okay, on to the next one. Okay, so we've got to draw the graph. On the graph, draw y equals 2x plus 1. Now I would do a little table of values. And we need to go between -1 and 3. So -1, 0, 1, 2, 3. We probably won't need all those points, but if we start at this end, 2 times 3 is 6, plus 1 is 7. Then we do 2 times 2 plus 1 is 5. Hopefully you can begin to see the pattern. 1 times 2 plus 1 is 3. 2 times 0 plus 1 is 1. and that gives us -1. If you look, you're going down by 2 each time. Okay, now we need to plot them. So that's your x value, that's your y. So 3 and 7, which is halfway between 6 and 8. 2 and 5. Well, that made this easy, have they? 1 and 3. 0 and 1. -1, -1. Right, really, really important. We've plotted them. We also need to a straight line through them, which is always fun because I can never get it to work. So we've done our straight line, and don't forget to label it. Y equals 2x plus 1. Now, next question, question 15. If you add two different prime numbers, the answer will always be even. Right? Jim is wrong. Explain why Jim is wrong. Well, let's actually write our prime numbers out. So we've got 2, 3, 5, 7, 11, 13. Well, if we add two odd numbers together, we get even. But Jim has forgotten that 2 is actually a prime number. So 2 plus 3 is 5, which is odd. So basically, Jim has not included the only even prime number, which is 2. Right, that should get you enough marks. And the counter example actually is fine. So any 2 plus any of those numbers would be fine.